Welcome to question 10 of the 2008 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAR. So let f be the function f of x equals e to the power of 2x minus 1 with the domain of the real number system. And for part A we're asked to find the rule and the domain for the inverse function. So the first thing we're going to do is let y equal f of x. Therefore we have y equals e to the power of 2x minus 1, and now we're going to swap x and y to find the inverse. So therefore the inverse is x equals e to the power of 2y minus 1. And it's very important in your exams to actually state this. And that's to give an explanation for why you've swapped x and y. It's not for no reason, it's to find the inverse function. Next up we need to solve for y. So we can start by adding 1 to both sides of this equation, and that will give us x plus 1 is equal to e to the power of 2y. To continue solving for y we need to determine an equivalent log statement, and that will give us 2y equals log, and the base remains as base e, and then we'll have x plus 1 inside here. And finally we need to state using correct notation, which will include giving the domain of the inverse. So dividing both sides by 2 will give f negative 1 of x is equal to a half log e of x plus 1, so that's the rule. And now we need to go about finding the domain of this graph. So if up here we create a small table which has the domain and range information for the function f and the inverse, we know that the domain of the original function f was the real number system. And by inspecting this asymptote here, we can see it's been translated 1 unit in the negative x direction, giving a range of -1 to infinity. For the inverse function, the domain and range simply swap, which will give a domain of -1 to infinity and a range of the real number system for the inverse. So therefore we can say that the inverse has the rule where x is an element of -1 to infinity as the domain. So that is the full answer for part A. So from the examiner's report we can see that 45% of students received full marks for this question, and that many students did correctly find the rule for the inverse function, but neglected to give the domain despite being asked for. Students must be careful to explicitly use brackets for compound arguments of functions, and that's because common incorrect responses included having x plus 1 not inside a bracket. So students just need to be really careful that they do all their working correctly, and that where necessary brackets are included. For part B, we're asked on the axes provided, sketch the graph of y equals f composed with f negative 1 of x, so a function with its inverse, over its maximal domain. So the first thing we need to remember is that f composed with its inverse function is simply equal to x. So the graph that we're actually going to sketch is a straight line of y equals x. The slightly harder part here is that the maximal domain isn't the real number system. And that's because there's a second thing that's really important when sketching composite functions, and that is that the domain of the composite function is equal to the domain of the inner function. And in this case, the inner function is f negative 1 of x, which we found previously to have this domain of -1 to infinity. So we're only going to sketch this graph from -1 to infinity with a rounded bracket. So keeping all of that in mind, we can now sketch the graph, and it will look something like this, where it will continue off in this direction, but it will stop down here at -1, -1. It will pass through the origin at 0, 0, and just to provide a scale on axes, this would be -1 and this would be -1. So that is the graph of f inverse of x over its maximal domain. So in the examiner's report we can see that only 19% of students got this correct, and that the examiner's report states that students should be aware that the composition of a function and its inverse results in y equals x over the appropriate domain. And just to reiterate what we discussed on the previous slide, we said that f composed with its inverse of x is equal to x which is also equal to the inverse function composed with f. So either one of those compositions results in the line y equals x, and again it's over an appropriate domain, which comes from the domain of the inner function. Rather than realizing that that composition did result in y equals x, many graphs were either exponential or logarithmic that the students gave. Students who drew the line y equals x often drew it over R, even though they had stated the correct domain in part A for the inverse function. For part B, we're asked to find the function f composed with negative f inverse of 2x in the form ax over bx plus c, where a, b and c are real constants. So the first thing we're going to look at is what negative f inverse of 2x is. So down here we can see that the rule for the inverse function was a half log e of x plus 1. So we're going to multiply that by a negative 1 out the front, so it will become negative a half log e of 2x plus 1, and that's what we're going to put inside the function of f. So therefore f of negative f inverse of 2x is simply equal to f composed with negative a half log e of 2x plus 1. So that is going to equal e to the power of 2x, but wherever there's an x we're going to put negative a half log e of 2x plus 1, and then we're still going to have this negative 1 here, so minus 1 out to the right hand side. This multiply by 2 and divide by 2 will cancel, and using one of our log laws we can move this negative up as a power. So this is going to equal e to the power of log e of 1 divided by 2x plus 1, and then we're still going to have minus 1 here. And if we realise that e to the power of log e are inverse functions of each other, so they're going to cancel each other out effectively, this is essentially going to equal 1 on 2x plus 1, and then we still need to subtract 1, but we're going to rewrite 1 with a common denominator, so this is going to be minus 2x plus 1 over 2x plus 1, and if we now subtract that fraction away, we're going to have 1 subtract 2x plus 1, so we're going to have 1 minus 2x minus 1 divided by 2x plus 1, and then this 1 and the negative 1 will cancel, which means the answer for this question is simply minus 2x over 2x plus 1. So that is the answer for part C. So once again, only about 20% of students received full marks for this question, and the examiner goes on to say that many students were able to find negative f inverse of 2x, but then did not know how to proceed or were unable to simplify their expressions correctly, with negative 1 often disappearing during the process. So that negative 1 was part of the original function f of x. Again, many students found the algebra for this question difficult. So it's another timely reminder that being able to work with log laws and exponential laws are an important part of exam 1.